Welcome you all to Research Park YouTube channel. I am Dr. V. Chandra, and in this course we are going to talk about the analog and linear electronic circuits. So let's start from the unit first, that is single and multi-stage amplifier. So basically we are going to talk the two different types of the amplifier, BJT based amplifier and MOSFET based amplifier. So here is the syllabus. If we look into the syllabus carefully, we are going to talk about the bipolar linear amplifier, load line analysis, small signal models, and followed by the the bunch of things. So we'll look into the all these things. So first question is that what comes in your mind if you are listening the word amplifier? So just check it here. Amplifier, I have written the two words. One is one have the font size little bit lesser and another have the font size higher. So you can say that both are just representing the word amplifier, but you can find that the bigger one have the much more visibility. You can see it from the longer distance. So this is actually the amplified one only. So this is our job to amplify the signal. So how will we do that? So check it here. This is the BJT type of the amplifier only. So you can give the input signals which may have the lower amplitude, and you can collect the output signals which may have the higher amplitude. So this one will be the amplified signal. So this is the basic purpose to design the amplifier. So we are going to start to talk about the BJT based amplifier, that is the bipolar linear amplifier. So what is the aim? So investigate the process by which a single transistor circuit can amplify a small time varying input signals and develop the small signal models of the transistor that are used in the analysis of linear amplifier. So in order to design your transistor based amplifier, the BJT itself is not enough to design your amplifier. So how will we do that exactly? So to do so, you must have to connect your collector terminal with some resistance, your base terminal with some resistance, and so you can connect some resistance with the emitter terminal. Then you can give the input signals that exactly you wanted to amplify in the base terminal, and you can collect the output amplified in the collector terminal. So this is actually the the how to design your BJT based amplifier. So here you can also see the common emitter transistor characteristics, the also the DC load line. DC load, how will you draw the DC load line? So first make your VCC is equal to VCE is equal to 0 and find out the value of the IC current, and also make your IC current equal to 0 and find out the VCE voltage at which your IC current will be 0, and then draw the straight line. Ultimately it will connect to both of the axes, means find the x-intercept and y-intercept and draw the load line analysis. So how will we do that? So we'll see in the next slide, that is it can be performed with the help of DC analysis. So we are going to study both the analysis, means how your BJT amplifier will act if you will supply the DC signal, and how will it act if you will supply the AC type of signals. So I hope all of you are aware that there are two different types of the signals, that is your DC and AC. DC means we are going to give the the voltage approximately 10 voltage, 15 voltage or 20 voltage, while in case of the AC means we are just going to give the very small signal of alternating current. The amplitude of your AC current, AC voltage may be 100 millivolt, 200 millivolt, in the range of the millivolt only. So how both types of the signals will behave in case of your different electronics components. So check it here. So in case of resistor, yeah, the R and R means it will act as a resistor only. In case of DC and AC, capacitor means it can act as open circuit in case of the DC model, while it will act simply capacitor in the AC model. Similarly, you can just check it. So let's start from the DC analysis. So first thing is that DC analysis means what will happen if I will supply the DC voltage of 10 volt or 15 volts. So for the time being, let's consider the voltage is of VCC. So this will actually the power, this will actually the DC voltage that will give the sufficient energy to amplify your input signal or the AC signal. So in order to find out the the amplification, this one is mandatory to do the DC analysis. So how will we do that? So first you have to find out the two major things, that is how much the amount of the IV current will flow through the base terminal and how much voltage will drop in between the collector to emitter terminal. So these are the two unknowns. So how will we find out these two unknowns? So first, use the KVL or KCL in the rightward direction or in the left direction. So just check in the rightward direction. You can write KVL VCC minus ICRC minus VCE minus IERE is equal to 0. So this is your first equation. Similarly, in the left direction, you can write VCC minus IVRE minus VBE minus IERE is equal to 0. So there are two equations and two unknowns. So with the if you will solve these equations, you will get IB current and your VCE. So with the help of these equations, you will get all the unknowns. Like you can also find the IC, IE, since you already got the IB with the help of another equation and the value of beta. Since your IC is equal to beta IB, from there you can find out your all the currents. Now coming to the AC analysis. So how your BJT will behave if you will supply some AC voltage. So here is the slide. Just check, the left side is representing the BJT and right side, if you will check, that is representing the equivalent circuit. So this slide actually belongs to the small signal hybrid biequivalent circuit of the bipolar transistor. So we can have the different types of the equivalent model techniques, but in our syllabus, mostly we are going to discuss about the hybrid biequivalent circuit. So therefore, I have drawn the equivalent circuit, which is, which is comes under this hybrid biequivalent circuit. So if you will check carefully, then your VBE terminal is simply replacing by the resistor R pi, and your collector terminal is simply replacing by a current source of GMVBE. Also, you can connect a RO in parallel to this current source. The RO may be the very high resistance, so you can also neglect, but you may connect it. So this is actually the equivalent circuit of your BJT. So now let's use this equivalent model of the BJT, that is in order to do your small signal analysis. So first image is actually the amplifier circuit, BJT based amplifier circuit exactly. So there is a VS of AC input that exactly we wanted to amplify, and other things, your RS, RC, all these are the registers. So here is your transistor, and you are going to collect the output across the collector terminal. So how will we do the AC analysis? So first draw the equivalent circuit. So in the right side you can see, first replace your VCC and draw the equivalent circuit. So we are going to collect the output across this collector terminal. So with the help of this equivalent circuit, you can also draw the equivalent circuit, which exactly you can utilize to find out the amplification gain. So how will we do that? So in order to find out the gain, you must have to find the voltage output and voltage input. Then only we can calculate the gain, that is equal to the V out by V in. So just check, we can replace this transistor by two different models, where R pi is your resistor and GMV pi is your current source. Also you can put R naught in parallel with the current source, which R naught may be the very high, so you may neglect or you can use in the parallel. Also, instead of the using your GM-Vpi, you can also use the beta into IB of the current source that will be in the current gain parameters, or transconductance mode you can use GM-V. So both are the same circuits only. It depends what type of the circuits you wanted to use, depends on your analysis. So here, further analysis of your gain, that is how will you find out the gain. So in order to find out the gain, now first replace your transistor by your hybrid equivalent model, that is your resistor is of R pi, current source is of GM V pi, and then RC is in parallel with your GM V pi, that is where you are going to collect the output voltage. In the left side, RB is there, which is connected with the source voltage. So how will you get the gain? So first find out the V out, which will be equal to your VCE, which is equal to your current. Since current is passing GM into V pi and your resistance is RC, so output voltage will be GM V pi into RC. And in order to find out the input voltage, you can find out the V pi. Use your voltage divider rules. You will get the voltage V pi is equal to R pi divided by R pi plus RB into Vs. Vs is your supply voltage, that is your input voltage. Now use your equation, that is gain is equal to V out by Vs, and put the value of V naught and Vs. Finally, you will get this gain of minus of GM RC into R pi divided by R pi plus RB. So these are the basic way to find out the gain. So similarly, we'll use these type of equivalent circuit in order to find out the gain in all the upcoming circuits. So in the next session, we'll discuss the analysis of the common emitter amplifier, then the common based amplifier, common collector amplifier, and also we'll look into the multi-stage amplifier using the same hybrid pi model. So thank you for listening me. If you have any questions, you may just drop a comment in this video. Thank you.